borrow. 101 minus 0, 1, 1. Okay, 1 minus 1, that's a 0. But now we get this column here. 0 and a 1. 0 minus 1. So what you got to do is basically borrow 1 from this column right here. Cross that out. So that's a 0. And we make this one a 1, 0. So now, for this row here, that's a 1. 0 minus 0, 0. Okay? So, remember to borrow from that next column to the left. So let's do another example, just to make sure you're tracking with that one. Example 1, 1. Let's do 1, 0, 0, 1, minus 0, 1, 1, 1. Okay, so 1 minus 1, 0. Uh-oh, we're already in trouble. That's one. So we gotta borrow from this one over here, but there is no 1. So that means we gotta borrow from this one. So that's a 0. And that's a 1, 0. And we're still over in this column. We're looking at this guy right here. So what we're going to do is we're going to borrow a 1 from this one, bringing that 1 down to a 1, and this a 1, 0. Okay? Because remember, next thing below a 1, 0 is a 1. And now we've got a 1, 0 up here. So 1, 0 minus 1 is a 1. 1 minus 1, 0. 0 minus 0, 0. Okay? Again, do a sanity check. Let's go to decimal. What was our original language here? It's 1, 0, 0, 1. That's a 9. And this right here is a 1, 1, 1. What is that? That is a 7. So 9 minus 7 should be equal to 2, and it is 1, 0. Okay? Okay, multiplication. Let's use our kind of the same pattern here as the 4 rules. Zero times a 0, 0. 0 times a 1, that's a 0. 1 times a 0, that's a 0. 1 times a 1, that's a 1. Looks surprisingly similar to an AND gate, right? Okay, so let's go back to decimal world. So decimal, we use something, basically it's called the sum of partial products. Let's do a simple example. 36 times 18. So what we do is use the 8. 6 times 8, 48. 3 times 8 is 24 plus 4, 28. Now, we multiply times 1, but notice how we're going to start right here. Okay? So, 1 times 36 is 36. That's the partial products. That basically using 8 right here, using 1 right here. And all you do is summate those. 8, 4. Carry our 1 up here. You guys have seen this before. 648. Okay? So basically, we've shifted over 1 anytime we use a partial product. Same thing with multiplication. So, in binary. So let's multiply. There is 1, 1, 0 times 1, 1, 1. So, start off, let's do this guy right here for 1. So 1 times 0, 0. 1 times 1, 1. 1 times 1, 1. This is green for this guy. So it's 0, 1, 1. And let's use red for this one. So that's 0, 1, 1. Then all you do is summate them just like we did upstairs. So 0, 1, 1 and a 1 is a 1, 0. So 0, 1. We got our 1 carried up there. So we've already got 2 1s in there. So that's a 1, 0, 1. So we had to carry that 1 over there. So 1 and 1, So written all out, our answer is 101, 01, 01. Okay? So check, just to make sure we are doing this right. So what is this? 110, that's a 6. 3 1s, that's a 7. So ideally they should give us 42. Is this equal to 42? 2, 8, 32. Oh my gosh, it's 42. Check. Okay, let's go into division. So division is just like regular division. Just think about how many times it can go into it and what's the remainder. So how many times, how many, what's the remainder? Okay, so let's just go right into it. So let's divide 1 0 1 0 1 0 divided by 1 0. So just write it like you would longhand division. So how many times does 1 0 go into 1? Well, 0 times. How many times does 1 0 go into 1 0? Well, once. What's the remainder? 0. Okay, how many times, bring this guy down. It's a 1. How many times does 1 0 go into 0 1? 0 times. Bring this guy down. How many times does 1 0 go into 1 0? Once. And our remainder is 0. Bring this guy down. 1 goes in 0 times. We'll bring this guy down. How many times does it go over there? Once. Okay? So let's do 1 1 1 0 0 divided by 0 1 1. Okay, so again, write it just like longhand division. 1 1 1 1 0 0. How many times does 1 1 go into 1? 0 times. How many times does 1 1 go into 1 1? Once. The remainder is 0. How many times does it go into there? 0. 0. Okay? That's pretty simple. Okay, so we are going to go into 1s and 2s complement and signed numbers in the next lecture. But that is the brief binary arithmetic, addition, subtraction, multiplication, and division.